My name is Mark Emberton. I am Dean of the Faculty of Medical Sciences here at UCL. What's been fascinating about our research work is that it's been entirely dependent on developments in physics and engineering. And our role as surgeons has been to take the problems to our engineer colleagues and work with them to develop solutions. The marriage of engineers and surgeons is a good one. Surgeons generate problems, engineers love problems because they generate solutions. So in other words, we are the translational arm of engineering that can apply new developments in technology to immediate patient care.
What makes UCL engineering special in this particular area is the fact that we are deeply clinically engaged. We solve problems alongside clinicians. We solve problems alongside medical academics who have a deep engagement with clinical problems. And that places us in a unique position. I think one of the most important achievements is the establishment of the Aspire Create initiative.
My name is Royal National the Aspire Senior Lecturer and Head of the Aspire Centre for Rehabilitation Engineering and Assistive Technologies. The centre is actually a partnership between UCL, the RNOH and the Aspire charity. And the reason why these three have come together is to address a clinical need where better rehabilitation strategies and technologies are needed, as well as the need to advance assistive technologies. The Stanmore site has a long history of excellence in research and clinical delivery. UCL, in partnership with RNOH, are developing a new Biomedical Engineering Hub. And we will have very soon a new institute building where clinicians and engineers will work alongside to develop the technologies of the future. Not only we are doing cutting-edge research, trying to understand the underlying mechanisms underpinning impairment, but also gives us unique opportunity to translate our basic research into clinical practice and into the wider world.
My name's Pendergrass and I am Senior Lecturer in the Institute of Orthopaedics. My research is focusing on interfacing the soft tissues of the musculoskeletal system with artificial implant materials. We have to use skills in engineering, skills related to the strength of implant materials and how we actually engineer a device to be put into the body. So without that union, we wouldn't have been able to achieve what we have, which is taking a model of deer antler, looking at how they breach the skin barrier effectively, translating that into an engineering solution for lower and upper limb amputees. By building this unit, it will mean that new solutions to really, really complicated problems will be more easily solved.
Royal National Orthopaedic is a world-leading clinical centre of excellence for treatment of neuromusculoskeletal conditions, orthopaedics conditions, and fundamental to our existence here at the Stanmore Campus is our partnership with University College London, our academic partner, which we work in very close partnership with. Many decades ago, after the war, there was an Institute of Orthopaedics set up here out of the clinicians and engineers involved in building implants for patients, spinal injury developments. The link between engineers, academics and clinicians is fundamental to developing services for patients to improve their lot.
The case we're about to do today is a very good example of UCL research being translated into clinical practice. We have a young man, age 52. He needs his hip replacement to last as long as possible, ideally 50 years. He has had 2 major operations to try and keep him away from hip replacement. But now's the day we're going to have to give him hip replacement because he's just simply not able to do activities of daily living. The building is going to put engineers right next to surgeons. It's going to enable clinical data to be used by engineers who can then make the most of it and give it back to the clinicians to make their operations better.
When I was appointed director of the division, the key mission was to become the translational arm for engineering in all its aspects. What we've done in the last 3 to 4 years is develop a very, very good relationship with a full spectrum of engineering. The creation of a new surgical engineering hub will be the realization of that dream. I see the main role for the new building on the Stanmore campus as being a centre to develop new materials. That's certainly the future of bioreactive implants.
We are one of Europe's strongest centres for biomedical engineering research, and that's a capability we possess because of our engagement with the clinic and because of the direct engagement of clinicians and biomedical research scientists in our work, alongside, hand in hand, with engineers. And it's that style of work which is, I think, going to deliver the sort of innovations which are going to make a difference.